Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And why is it not a wait a sec? Okay, cool. All right. Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And today we are back again with another launch. And this time we will see the Relativity Space doing wonders. Well, this is a new company, as you may wonder, like there are so many startups which are coming up, uh, making all those small sat launchers and everything, but this is one of them, obviously, with a higher payload capacity, with much bigger ambitions, and well, they have already demonstrated something on the ground itself. And we will talk about them fully. We will get to know them. We will see what they are, what do they do. And before that, I welcome you all. Hi Robster, hi Baba Yada, welcome to the stream. Blues Traveler, you are in India. Well, cool. I hope you enjoyed your holy year, and you are doing great. Hi Yash, how are you? So without any further ado, let's just jump into it, right? Okay, so uh, the Relativity Space is launching the Terran 1 rocket. So this in front of you is a Terran 1 rocket. This company itself is very what should I say, mini SpaceX like. I'll tell you why this is. This rocket is capable of around 8 900 kilograms to sun synchronous orbit and 1250 kilograms to low earth orbit. Well, we'll talk about the specs and all, but first of all, let's get to know the company itself. Oops. Yeah. So Relativity Space, what is special about it, and what makes it different from other companies is this. Yes, they literally 3D print the rockets, and you must be feeling like, well, we have seen so many things, so many startups 3D printing their rockets, right? Even Electron prints their engines. Well, yeah, Electron only prints their engine. That's the thing, because it is one of the complex part to make, and if you can 3D print those, it greatly reduce the complexity and overall cost. But they have taken that step a bit further, or not a bit, very much further actually. So they have what they do is they literally 3D print the whole rocket. Right now they are 3D printing 85% of mass of the rocket, which itself is huge. They 3D print not only their engines, they 3D print their tanks, the interstage, as well as both the tanks basically and the interstage. So this not only reduces the complexity and everything, but also makes the manufacturing very fast. Okay, and this is some new concept, a new way of manufacturing the thing. So we'll have to wait and see how this rocket would perform. So reliability increases, as you can say, 110 times fewer parts, 10 times faster production and whatnot. So this company was founded in 2015 with a goal of making this rocket, which is in front of you. And yes, it does look very similar to Starship, because yes, it's kind of what will be doing what Starship does. So this is the Terran 1 rocket, and this is the Terran R rocket. So Terran R means the reusable. So yes, this will be a fully reusable rocket, and this Terran R will come into a category of the Falcon 9. So the payload capacity, while being fully reusable, will be around 20 tons to low Earth orbit. So well, they are making some. That's why I said mini SpaceX, because the Terran 1 rocket looks more like a Falcon 1 rocket. I guess this is very similar to Falcon 1 rocket, and then this is a mini Starship which we can see. So so they have since I'm talking about, and yes, they have this goal of reaching the Mars too, and that is the reason why they are optimizing their rockets to work in the Martian environment and everything. So let's just have a look at the 3D printer itself. The 3D printer, what they call their 3D printer is the Stargate. Okay, and there, that is one of its kind 3D printer, one of the world's largest 3D printer. So the structures which they make, you can see in the bulkheads, the tank itself are 3D printed, and I don't think so we have this big of a 3D printer ever. So you can see how they work. So real faster design iterations and everything. So some, you can see the video which is being played, like how the um, machine actually 3D prints the tanks and everything, which itself is a very interesting thing to watch and see. So this is one of the reasons why we will have to watch out for this rocket during the max Q, because max Q is when the rocket experiences the most aerodynamic pressures, vibrations and everything, so most stressful point in the flight. And since this is a new way of making the things, so the structural integrity will be tested during the max Q to its fullest. So it will be interesting for this rocket to see whether this rocket will pass the max Q or not. Okay, so that's what I was saying, the 100,000 plus parts during the normal traditional way of making the rockets, less than 1,000 part obviously. 2-month build time, 24-month build time, 6-month iteration time, so the turnaround time is also very less. Simple supplier chain, software defined factory. Yes, they don't require much of the human intervention, so all the things can be controlled by the software itself. The quality control, the inspection and everything can be done by the this machines itself. And when it comes to rockets, well, you mostly rely on machines to do the inspections only. So because they need to be very 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 precise. So yeah, that's how it is. Now let me just move on to the next thing, which let's just have a look at the rocket now. Okay, so the rocket, what the rocket is. So this is, we'll talk about the Terran R rocket afterwards. Let's just have a look at the Terran 1 rocket. So this is the Terran 1 rocket. This is powered by 9 Aeon engines. So this is very much similar to Falcon 9 only, but kind of a mini Falcon 9, which is equivalent to a Falcon 1 rocket. So yeah, this is how it is. So this runs on these engines. We'll talk about the engines later, but this is a 2-stage rocket. The first stage is powered by 9 Aeon engines. The second stage is powered by 1 Aeon vacuum optimized engine, and the payload capacity, you can see 1250 kilograms maximum to low Earth orbit, but it is like to its limit. This is stretched exactly to its limits, because this factor which you can see right now is when you have around 200 or to 250 kilometers low Earth orbit, which nobody goes into. Their minimum requirement is 450 or 500 kilometers of orbit, and the payload the capacity will accordingly decrease, but still it is much higher than what we have for Electron rocket. So it comes more into the category of Firefly rocket, which they are making, and so it will be small to medium lift category will be small to medium lift launch vehicle. And you can see the payload bay, which you can see here. High altitude payload, 900 kilograms to 500 kilometers sun-synchronous orbit, which this is true. And you can see 700 kilograms to 1200 kilometers sun-synchronous orbit. And the cost per launch is around $12 million. So if you compare it with the Electrons, yes, it is much cheaper than Electron. So Electron costs per kg is around $300,000 to orbit, and this one cost per kg is around 130k per orbit, per kg to the orbit. So it's much cheaper, and and they obviously will have a much greater turnaround time because of the rocket itself being 3D printed. So yes, it's good. Now let's talk about the Aeon engine. So this Aeon engines, which you can see in front of you, runs on gas generators cycle. And guess what do they run on? Well, I told you they are looking forward to the Mars. So yes, this is a Methalox rocket. So they uses liquid oxygen and not methane, liquid methane exactly, but they use something similar, which is LNG, which is nothing but liquid natural gas, which has 97% methane and 3% other natural gases. So this is one thing which they do. And you can see they have already completed around 2000 plus test fires, which is like amazing to see. This rocket is 3D printed. Yep, this kind of, you can say not all the parts are 3D printed obviously, but 85% of the mass is 3D printed, which itself is such a big feat to achieve. So this, since I told you, this company was founded in 2015 and they have raised around 1.3 billion dollars in funding. So they already are a unicorn startup, and they are making such a good progress. Already had 2000 plus test fires, and they are making as I said, a methalox engine. The Aeon 1 is a methalox. Aeon vacuum is a vacuum optimized Aeon 1, and then the Aeon R, which will be much powerful. So it's like only one engine can replace all the 9 engines of the Aeon 1. So Aeon R will be very much powerful, which actually is needed. And talking about this rocket, well, so this is how the engine looks like. So this runs on gas generator cycle, which is here. You can see that this is most probably the first stage engine itself. The combustion chamber is regeneratively cooled, so that means the fuel is passed through the combustion chamber so that it cools it down, makes it on the operational, makes it always stay on the operational temperatures. As well as one more unique thing about this rocket is that this is autogenously pressurized. So yes, if you remember that meme which was going around on the YouTube shorts or Insta, where everyday astronaut suggested Elon Musk to have autogenously pressurized thing, which means the hot gases, for the RCS control of the Starship. So yes, the Starship itself has autogenously pressurization, and this rocket will also have that autogenously pressurization system. So what is that? So that is nothing. That simply means what you do is you heat up the fuel which you are using and then pass it back to the just a second. Whoa. Yeah, and then pass it back to the fuel tank. So therefore you don't need helium or some other gas to pressurize the fuel tanks. You can use the fuel itself to pressurize the fuel tank. So there are like tons of advantages of this system. You let go of the complex pressurization system, let go of the mass which requires of those bottles, which is required, the mass of those bottles and everything. You can obviously it is kind of it makes the system simpler, but it's kind of difficult to do. But this is not the first rocket to do it. Space shuttle used to do it. The Titan, one of the Titan rockets used to do it, if I remember correctly. And then the SLS is also using it. So yeah, this is one of those things. So in comparison, like how does this look like? You can see the Terran 1 rocket, which is going to launch today, and their future Terran R, which will be mostly their go-to rocket once this is completed. So yeah. And talking about the payload, well, this is good luck, have fun. This is the mission name which they are having, and the thing which you are seeing in front of you sorry, is actually the rocket, the payload itself. So this payload is nothing but a dummy ring which is there inside. There is no actually fairing on this mission. So there is a nose cone, that's it. So there is no fairing, and beneath that nose cone there is this payload. So this payload is nothing but a dummy ring of around 1.6 kilograms or something, and they are what should I say? Yeah, so they are actually this is a memorable thing for them to do, because uh, this is one of those structures which was printed from their first generation of 3D printer. So yes, this is one of the things which they are doing to kind of um, celebrate their journey, how far they have come. So yeah, so today in this launch, this will be mostly like a test flight. There will be no um, payloads and anything. So even no, there is not even a fairing, so there's just a nose cone there, because the fairing would look like that only, which I already showed you. The rocket would have a certain bulge, but we are not having that today because we are having a nose cone instead of a fairing. Okay, now what would be the mission trajectory? So there will be obviously the lift off the max q, which will be a very good thing to watch today, important thing to watch today, because we need to see how the 3D printed rocket structural integrity would stand during the maximum stress of maximum point, the stress, the maximum stress which it experiences during the flight. And then the MECO will happen, stage separation, the second engine start, the second engine cut off at 7 minutes 43 seconds, and the orbit will be reached. And you can see there is no deployment of the payload because nothing is gonna deploy. They are aiming for around 200 kilometers of low earth orbit. They are aiming a bit low this time, because obviously they don't want to waste so that they can what should I say, um, make sure the space remains clean and they can achieve what they want to achieve. So this is mostly a test flight. They want to test the parameters, and so accordingly, guys, have things in mind. So talking about the weather, well, weather is supporting too much this time, so only 10% probability of violating weather constraint today. And if they go for tomorrow launch, if the launch does not happen today, then it will be even reduced to 5%. So we hope that it launches today, but if it does not, then also things are looking good. Although the team is monitoring high level of upper level winds, so there's that. But yeah, so this is the thing. Let me just go to the stream. I guess they are already live. Nope, they are just making we can see that. Let me just right uh, yeah, okay. So they are looking in, you can see this is like their what should I say, brand video, which you can see it in front of you. So they have come a long way, but they still have to prove it today that they will be doing wonders today. So let's see how it will pan out. And we are, oh yep, we are t minus 54 minutes in counting. Everything is looking great, which you can see. And wait a sec, yeah, and you can see that there you go, the rocket itself in front of you, standing tall, waiting to fly previously. So you can see this is the first stage, this is the second stage, and the vent which is coming, the smoke coming in from the second stage itself suggests how there is no fairing in this there is only a nose cone and that dummy 1.5 kilogram ring which they have today. All right.
Welcome back. Thank you for joining us again from Cape Canaveral Space Force Station in Florida, where we are preparing for our second attempt at launching Terran 1, the world's first 3D printed rocket. Today's flight is named Good Luck, Have Fun, or GLHF for short. This is Relativity's first launch. We'll be bringing you live coverage from Launch Complex 16, which is our launch pad here at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Terran R.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch at Relativity Space. I'm responsible for supporting the teams that design, build, and operate our test and launch sites across the country for both our Terran 1 and Terran R vehicles, including operations on the stages, engines, and propulsion components. Together, we'll be guiding you through our second launch attempt today. Now, if you joined us on Wednesday during our initial attempt, you know we ultimately decided to scrub due to propellant conditioning issues. Before we get underway today, we want to share a bit more detail and explain how it impacted our first attempt.
Well.
During Wednesday's
Yep.
operations, a ground equipment valve was malfunctioning. This prevented us from having adequate control over achieving the cold temperatures we aim for with our liquid oxygen. The team has since fixed this valve and incorporated additional mitigations to get that liquid oxygen, or LOX, to remain at acceptable temperatures. Additionally, we've seen questions about why we opted to schedule our next attempt today as opposed to going again on Thursday. The team was able to quickly repair that ground support valve, so that wasn't the cause for the delay. Instead, it had to do with our propellants. For those of you less familiar with Methalox propelled rockets, our liquid natural gas is mostly comprised of methane. But there's also a little butane, ethane, and propane, which are higher order hydrocarbons. As such, methane, being the simplest molecule, boils off faster, lowering its concentration over time. When we load propellant, we do so in a way that achieves our optimal methane levels. If we were to offload and reload those same propellants after a scrub, our methane composition would be off. Instead, we bring in fresh propellants, and the fuel then needs some time to level off to the right compound mix before we make another launch attempt. The good news is that propellant loading is proceeding smoothly today with no reports of issues with our valves or our propellant temperatures. Now we're currently at T minus 50 minutes and counting. I did just receive confirmation that propellant loading is wrapping up for both stages. The range is green and the vehicle is healthy. However, we're keeping a close eye on upper level winds right now, since earlier forecasts were indicating marginal conditions for today's launch attempt. We use a combination of data from global forecast system modeling and real-time data from our weather balloons, which we are releasing periodically. We do this to determine if enough thrust vector control, or TVC margin, is there to overcome the atmospheric wind shear as Terran 1 approaches max Q. While winds at ground level today are acceptable for launch, remaining between 15 to 20 miles an hour, the upper level winds could impact our ability to gimbal the engines enough to keep us on course for our intended orbital trajectory. Current data is indicating we are a go for launch, but this is something the team is continuing to monitor.
Thank you, Arwa. Arwa will provide regular status updates over the course of the countdown. In the top left of your screen, you can follow our countdown clock to help follow along in our pre-launch operations.
Thank you, Rochelle. And now a quick reminder about the purpose of Good Luck, Have Fun. This is a first launch, meaning that while we're aiming for Terran 1 to reach orbit, our primary focus is on gathering the data and learnings necessary to develop Terran R, our much larger medium to heavy lift reusable launch vehicle. The lessons learned from this mission will also enable us to improve our software-driven approach to manufacturing.
And today's launch includes many firsts. Terran 1 is the first 3D printed rocket, which is 85% 3D printed by mass. It's in a race to become the first Methalox propelled rocket to achieve orbit. And if orbit is achieved, relativity
Well, guys, this
will
is
also become the first venture-backed space company to have successfully reached orbit on its first flight.
And it's worth noting that while Terran 1 will be capable of lifting 1,250 kilograms into low Earth orbit, or LEO, today's launch doesn't have a customer payload. We do, however, again have a memento on board, one that's quite unique to Relativity that we'll tell you more about later.
So liftoff
there is some
for
issues
3 hours.
with their end
This
only.
is time to troubleshoot any issues. If there are any unforeseen issues during the countdown, we can pause the launch sequence if necessary.
And as we await our first launch, let's take a minute to reflect on the path to this historic moment. In just 7 years, we've gone from an idea on the back of a coffee receipt to the 1,000 plus full-time employee company we are today.
Wow. Okay. Guys, let me just interrupt you guys for a sec. So, what they just told us the thing regarding the scrub which happened previously. Well, you got to know what actually happened, and that was certainly a new information for me that the liquid natural gas can't just be offloaded and onloaded into the rocket. So this is one of the things which is kind of a unique, will be a unique to this rocket, because this will be, they will be using this liquid natural gas in their rockets, and if there is a problem with the one of first attempt, then they can't they can't reload the propellants again and go for the second attempt. So if abort happens, there will be very less chances that they will go for the second attempt, until unless they have a new lot ready to go on the go to get loaded and be ready. Certainly a new information. So yeah, so this is how their rockets actually look like. This is the Stargate factory.
I actually have a photo of a Starbucks receipt where we wrote out the original vision of Relativity. Really, we knew building our own 3D printers, which had to be the world's largest 3D printers, was one of the first things that we had to figure out. So we spent the first couple of years really refining that technology, just frankly figuring out how to build a finance team, get customers, get any traction at all, really, just to start to breathe life into this vision that we were building towards, and having those first employees really start to define the values and culture of Relativity. Our first engine tests, our first igniter tests, our first Stargate prints of full-scale hardware, and man, I'll tell you, some of those early prints look like piles of metal and pretty crappy, so we really had to figure out how to refine the technology. Those early days, there were a lot of hard-won battles, but we learned really quickly and really started to hit an inflection point about 3 years ago. Sending that email to Mark Cuban, I just felt we had absolutely nothing to lose. 3D printing is the future. I really feel so lucky that we live in a special time where we actually have the tools, the momentum, and the ability as a company and as an industry leading humanity's future in space. This is the year we're doing it. We've got tons of great team members working on it every single day, and I believe it's a challenge for any team, but for our team, we've got nothing to lose. So I'm very excited and humbled by the people that have joined us and what it means to actually build this thing together.
So there you have it, guys. That was the intro for you for this company, how the 3D printing journey came into existence.
We often get asked, what is Relativity Space? Well, let me tell you, we are a rocket company. We build rockets designed to offer high performance and reliability while costing less to build and fly. This lets us put our customers first. Our long-term vision is to expand the possibilities for the human experience by creating humanity's industrial base on Mars. Our rockets, Terran 1 and Terran R, have already been met with significant market interest. To date, Relativity has announced nearly a dozen signed customers for commercial and US government payloads. Some of our customers include OneWeb, Iridium, NASA, and the Defense Innovation Unit. Currently, Relativity's customer contracts amount to more than $1.65 billion. We are a private venture-backed company, and to date, we have raised over $1.3 billion in capital, with our most recent $650 million Series E round. This funding has allowed us to make progress on Terran R, as well as get Terran 1 to today's launch. With that, let's take a step back and see how we're tracking towards launch.
We are currently at T-minus 42 minutes. The vehicle still appears to be operating nominally. The weather is looking good so far. We're still keeping an eye on those upper level winds, but other than that, we're tracking well towards a 1300 Eastern Time launch.
That is great to hear. Good luck, have fun is the maiden launch of our 3D printed Terran 1 rocket. Terran 1 is an orbital class rocket, and of course, reaching orbit would be a total home run. But as we've mentioned before, we're just truly looking for some important base hits here today. Notably, a key objective for today's flight is largely about proving our hypothesis that 3D printing is a viable way to manufacture a rocket, and it can successfully withstand the pressures of flight. Through robust ground testing, we're confident that we have a real shot at proving just that. And the more data that we collect from this first flight means that we'll have access to more insights. And this will give us the confidence that we're able to execute on Terran R. And it will help us solve all the hard problems that come with building a medium to heavy lift reusable rocket. As a business, we are following the Pathfinder product development approach. So the Terran 1 that you see on the pad today has always been our Pathfinder. It was designed to be a development platform for Terran R, and it has served us exceedingly well to date in that capacity as we've progressed through printing and testing ahead of today's launch. Arwa, what would we call success for today's launch?
Well, again, safely clearing the pad, getting out over the ocean, and passing the point of maximum dynamic pressure, or max Q, would be a big inflection point for today's launch. This is because it's the point where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight. This is the point in flight where we want to prove much of what has already been proven on the ground. During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter during flight, so passing this milestone would effectively demonstrate that 3D printed rockets are structurally viable. If we make it even further to stage separation, we will have achieved a full first stage flight, and that'll be another big accomplishment for the team. From there, we'll attempt to light the second stage and get Terran 1 to orbit.
So at that point, it's going to be so tough not to jump out of our seats if we get to that point. Just as a reminder, Stage 2 is targeting a 200 kilometer by 210 kilometer orbit, which is not a traditional orbital target. However, that is our target for today, given that this is our first launch and not a customer mission. There is no customer payload on this flight. Instead, to celebrate how far we've come, we have mounted our first ever metal 3D print from the first generation Stargate printer inside of Terran 1's nose cone. And while we're on the topic of setting expectations, we will also note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings. And as a result, the video connection could be spotty. So in the event that we do lose video, we will do our best to keep you up to date as we receive telemetry.
And I just want to update here that our launch time is set now for 13:45 Eastern. We have updated that with the range, and you can follow along on the time clock on the top left-hand corner. We do have strict safety protocols in effect for today's flight and are closely coordinating with the FAA and Space Launch Delta 45. These protocols are standard for all launches and ensure that no one would be in harm's way if there were to be an anomaly. The window for today's launch attempt opened at 1300 Eastern, and it lasts for 3 hours. The pad was cleared of all personnel again at T-minus 4 hours, followed by the start of propellant loading. Propellant loading is now nearly complete, and we're going to top off our tanks and condition our propellant shortly. At approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal flight computer takes control of the countdown. Now, while we wait for T0, let's talk about the process that got us here once again. Terran 1 is 85% 3D printed by mass. The items that aren't 3D printed include rubber seals, computer chips, valves, and other similar items. We see 3D printing as an automation technology, and we believe that long-term 3D printing will rapidly democratize space. We've already been able to unlock rapid part count reduction and rapid design iteration, and we're still very much in the early days of what's achievable. Now, we use two classes of printers here, powder bed fusion or PBF, and vertical wire arc additive manufacturing or WAM.
For those of you that are tuning in today for the first time, powder bed fusion, or PBF, is a process that uses a heat source such as a laser to sinter or fuse together particles in a layer-by-layer process. Let's show you an example of a PBF printed part. What you might see on the screen right now is a development part. Specifically, this is a development part that we use for our Aeon R engine. It's an example of a turbopump housing. We use PBF to print our 9 Aeon 1 engines and the single Aeon vacuum engine on the second stage for Terran 1. We have been able to increase reliability through lowering our part count with PBF.
And now let's maybe pull up an example of one of our WAM development articles.
That is interesting, actually.
Our proprietary Stargate printers use WAM for printing the vehicle structure. We developed a proprietary metal alloy that begins in a wire spool and is then fed into a Stargate printer. It's then heated and cooled rapidly to form small beads that, in succession, create the vehicle structure, layer by layer. That includes the Stage 1 and Stage 2 tanks that hold the propellant, their internal ribs, the common domes, and of course, the nose cone. This is essentially what makes up the bulk of the visible part of the vehicle on the pad, except now it's painted white instead of the native silver that you see here. Now, I do want to mention that Terran 1 was again vertically printed using our 3rd generation printer, but our 4th generation printer will move horizontally to increase print sizes for our next and much larger vehicle, Terran R.
Wow.
But of course, first, we have to launch Terran 1.
That is right. We have to launch Terran 1 today. So for those of you that missed Wednesday's broadcast, let's do a refresher about the Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall with a 7.5 foot diameter. Starting from the left-hand side and the bottom of the vehicle, there are 9 Aeon 1 engines. Each of these engines has a thrust capability of about 23,000 pounds at sea level. This gives us a max total liftoff of over 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle. We have thrust vector control actuators, or TVCAs, on the engines to gimbal the engines during flight. We have completed more than 2,000 engine hot fires, and with 10,000 seconds of runtime across the 191 Aeon 1 hot fire tests. The 9 Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the loads from the engine thrust. And above the thrust structure is the stage with the WAM printed tanks that Arwa just shared about. This holds liquid oxygen on the top tank and liquid natural gas on the bottom tank. These tanks are pressurized using an autogenous pressurization system. We tap off a portion of the propellant from the engine, and this is run through heat exchangers that are mounted on the engines. The liquid propellant is converted into a gaseous state, and then this is piped back into the top of the tanks to maintain our required tank pressures. Above stage 1 is the WAM printed interstage, and this holds our stage separation mechanisms. For stage separation, we use a pneumatic pusher system. And above the interstage is stage 2, which has a single Aeon vacuum engine. This engine has a thrust capability of more than 25,000 pounds in vacuum and has the capability of multiple restarts. Stage 2 also has WAM printed tanks just like stage 1. And above stage 2 is the WAM printed nose cone. For future missions, this would be replaced with a fairing and also have a fairing separation system. As we mentioned, there is no customer payload for today since this is our first launch, but we did design Terran 1 with a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to sun synchronous orbit, or SSO, for customer missions. All data from Terran 1 development will be fed into Terran R. But our Terran 1 rocket is only part of the formula. As we get closer to liftoff, Arwa, how about another status update?
Yeah, of course. We are now at T-minus 31 minutes and counting. We're not tracking any current weather violations. As I said earlier, we're still going to keep an eye on those upper level winds, but the range is still green and the vehicle systems are still nominal. So as of now, we're still a go for our scheduled launch time. Now for our new viewers, here's a little more info about the systems you're seeing on the pad. The rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. This is the black vertical truss structure you see there behind the rocket. And then you'll also see 4 large towers surrounding the pad that make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, we have 4 much smaller black posts called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame you see at the bottom right of your screen is the flare stack. No need to worry there, this is intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see here, but there it is. The small slide-looking structure beneath the vehicle is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs the exhaust plumes away from the vehicle. You'll also see what looks to be 3 different levels under the rocket. The largest and lowest level is the pad deck, and directly above it is the launch table. This is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. It transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system, or hold downs, and the quick disconnect, or QD carriages that provide propellant and other commodities to the vehicle while it's on the ground. And once again, a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare for today's second attempt. So thank you all so much for your incredible work.
These teams have also supported our rigorous test campaigns. Let's go ahead and take a look at Terran 1's journey to launch.
All right, guys. Well. You just saw some big words from them, but here you can see the 3D printed tank, a 3D printed nose cone, and those all those 3D printed structures have a what should I say, a 3D printed trademark, because everything which is 3D printed has those layers in it. Okay, so those layers are visible here also, but one thing which actually amazed me was how this what should I say, they said they will be using the things to be horizontally made, which is kind of difficult to do, but they will be doing it. So and yes, there we are having some connection issues, not from my end but from theirs. So yeah, right now things are looking good. Everything is going as per the plan. We are T-minus 28 minutes from the launch. and we should be looking good for an on-time liftoff. But again, this is an test flight and things can go wrong. I'm not so much optimistic about launching it at this point of time. I mean, at T minus 28 minutes, but we never know. So let's keep our hopes high and see how this will go.
Now, as we approach T minus 25 minutes, we're going to stand by for a situational briefing from the launch director, Clay Walker, and Mission Control. Let's go ahead and listen in.
Hopefully, they Pratim. Let's see. This will, like, yes, there are so many maiden flight launches that I have streamed on this channel, but will this be a successful first one? That is yet to be seen. Um, I am hopeful that this will be successful because they know what they are doing. They have not rushed it at all. They have completed around 2,000 plus static fires, but still. A new technology is being used, 3D printed tanks. So structural integrity, how well those 3D printed structures would hold during maximum stresses, that is yet to be seen. But hopefully this will be the first time we'll have a successful maiden launch of a rocket company on this channel. Okay, so we are T minus 26 minutes and counting. Everything is going good. Let me just update my timer. If you have any questions, you can ask me, guys. So we are looking good. Yes, you can see this is the mission control room. Not so many people out here, but the people are here. Most important people are out here to make sure everything will go as per the plan. Things are looking good, although they are monitoring the upper level winds, but let's hope that does not happen. uh, those are in control only, and we shall see the launch of this rocket. So right now this rocket is more.
If you're just
Okay.
tuning in, we are now awaiting a situational briefing from Clay Walker at around T minus 24 minutes.
All right. Alrighty. Yeah, so I was saying that we shall be seeing a good liftoff today. That's what I hope. And terrain, terrain, or terrain. English pronunciation is something which I actually lack. So pardon me for that. But Relativity Space, will they become the first company to go reach space? First ever company which is powered by Methalox engine to reach orbit, because this title was supposed to go to the Chinese Zuki 2 rocket. Methalox, that was a Methalox powered rocket, but it did not reach the orbit. So will this be the first ever rocket to reach the orbit powered by Methalox engine? Well, yes, that is yet to be seen. We were supposed to get a briefing right now, but I hope he's taking his time to verify things and get us a good briefing. Hopefully we don't have any lag or any um, stopping in the countdown. Hopefully, let's hope for the best. There you go, a cute little rocket. um, this rocket right now looks more like a side booster to me. Because you can see the vent which is coming from the second stage is very much near to the nose cone, because there is no fairing on this one, only a nose cone. So yeah.
I'm hearing here that the team is looking into those upper level winds before we proceed with the situational briefing. We should have an update here in just a few minutes.
All right. And there you have, if you can see in the background, the methane um, gas flare that is actually needed, and that is a trade that used to be a trademark for the Starship launches, right? We have seen that, but I think they have now removed that. But in initial days, this is a thing which companies do to make sure the flammable gases which are not which are not needed are disposed of properly, so that they don't catch fire when they need to, when they don't need to. Obviously they should catch fire when they need to. Okay. Hi Kathy, Kathy, welcome to the stream, watching from the Space Coast. Wow. Hopefully, so this is actually being launched from Space Launch Complex 16, and I think that means this will be the first launch after 35 years from Space Launch Complex 16. So that would be interesting to see. And hey Labrad, oh, after so long you are back. Welcome to the stream, dude. I hope you are doing great. And Robster, yep, good luck to this rocket. But they are looking in for the upper level winds, and that is why we are awaiting an update, which should have happened already, but hasn't happened. Hey Remiji, welcome to the stream. Yes, you are also after. Okay, I am seeing you after so long. And there is no wildflower today. I guess she did not get the notification.
Announcement on Countdown Net is the LD. We're holding the clock at T-minus 20 minutes due to upper wind violations. Stand by for a new T0 time.
And as you just heard from Clay, the team is going to hold at T-minus 20 minutes. We're going to continue evaluating those upper level winds and get a new T0.
Not good. But this is how it is. So we are at a hold due to the upper level winds. All right, Remiji, understood, understandable. Yeah, so yes, there is a hold which was supposed to be there, but not. I thought this hold would most likely be because of an technical issues, but that was not the case. It is more likely because of the the weather. Weather is actually good. Weather is amazing, and that is one of the reasons why we have a higher upper level winds, because the cloud conditions are marvelous today. Yeah, so because of the high upper level winds, right now we are at a hold, and what you are seeing in front of you, the gases are
Those white clouds that you see coming out
okay.
of the
She will
rocket
explain.
are due to venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds when it's coming out.
Cool, isn't it? Okay. So, can you like hear me, guys? This is a thing which is not from my end for some reason. All right. Okay. So we are at hold of on at T minus 20 minutes. Everything is not looking good right now. Although, hi Courtney, how are you? Okay, we can hear you. Cool. So yeah, I was saying we don't have any other update. There is an hold because of the winds. We'll have to wait and see if they will go out today. Although they had a 3-hour launch window, which started at around 11, around 30 minutes before. So there is still like 2.5 hours left into the launch window. So we'll surely see how if that happens or not. So right now we are at a hold.
For those just joining us, we are at T minus 20 right now, and we're actually holding the clock due to upper level winds. The team is currently evaluating this, and we'll provide an update as soon as they have it. However, the vehicle is healthy and the range is currently green, so as soon as those upper level winds slow down a little bit, we'll be able to provide another update.
Whoa, look at that. Just look at that. You can see those engines. Wow, that is up the skirt, right? For us, at least, for the rocket fans. Well, yeah, so we got some glimpses inside the engine bay. How does it look like? Although it was covered with, what should I say, ablative coating, not coating or some material. Was it ablative or was it, how would it work during the flight? That is yet to be seen. But surely that was actually, that can be seen in Firefly also, if I'm not if I remember correctly. That is some sort of heat resistant material which they use to make sure that the fire from the engine does not go inside the plumbing of the engines. So yeah, this is what they do. So that coating, that weird looking cloth kind of a thing was to prevent that.
For those just tuning in, we did hold the clock at T minus 20 minutes today, but we're expecting a briefing in the next 5 to 10 minutes on what's happening with the upper level winds that were the reason for us holding the clock. We'll continue listening in and hopefully everything sounds good.
Yes, Premiji, it's yeah, 4 hours from now. I'll have to see whether I'll stream that or not, because it will be very late night for me, around 5 a.m. or so, and I do have some work tomorrow. So let's see. But I am streaming this one, so hope for the best. So yes, this the launch window for this actually, what should I say, completes before the Electron rocket itself launch itself. So it's like 2 hours before the launch window will be completed, will be finished. So uh, for sure we'll get to know whether this will be launching or not. And that is actually that is launching from Virginia, that Electrons rocket. It's so yes, it is in the US only, not in the New Zealand. But yeah, it will be well way after that, after this launch, the launch window for this rocket ends. Why is it so lagging today? I don't understand.
For those just tuning in, we once again held the clock at T-minus 20 minutes due to weather issues. Unfortunately, upper level winds are currently marginal, so the team is evaluating live data to determine if we can go ahead and keep rolling the clock or if we need to pause for a little bit longer.
And as we wait on that additional data on the upper level winds and as we get an update from the team, let's go ahead and take a moment to get an idea about all the work that the integrated performance team does for Relativity Space.
Hi, I'm Ryan Kraft.
I'm Katie Wallace.
My name is David Brown.
I'm the Director of Integrated Performance at Relativity.
I'm a vehicle simulation engineer.
And I'm a staff vehicle simulation engineer.
One of the key things that we focus on in the department is connecting all the different teams, making sure the structures work with the engines work with the software, and the software works with the electronics hardware. I was lucky enough to work in a few different hardware startups. This is actually number 5 for me. Worked on electric vehicles, race cars, rockets, and manned spacecraft.
A typical day in the life for me at Relativity can vary a lot, but in general, it'll involve running a lot of different trades and analyses, helping with mission planning tasks, and also building up new simulation capability.
I've spent my entire career working on simulation controls. I started off working in the automotive industry on hybrid vehicles, and later moved on to motorsports and general consulting for other industries.
When I saw what was going on at Relativity here about 3.5 years ago, I realized this is the coolest place to be on Earth, and I wanted to join the team. Some of the things that we get to learn every day, I don't think you can learn anywhere else, and the team that I get to do it with just makes it even sweeter. Specifically, some of the big challenges are around figuring out what parts of accepted practice in the rocket industry still make sense for us, and where we should change things, or when we should just throw it out and start over with a completely new approach.
I think one of the most exciting challenges is getting to work on Terran, especially because our team gets to be really involved with the early design, running different trades and analyses and trajectories. And it's challenging because it's never been done before, but it's really exciting to really get to help shape this new vehicle.
My role is usually involved taking small components and subsystems and integrating them into complex system models, which then have great predictive capabilities. What I find most exciting about this is then taking these models and using that capability to help guide design work.
There's a lot of places where an engineer can come in today and still define how Relativity will do rocket engineering for the next 5 to 10 years. When we look for candidates in the integrated performance team, the main thing that we're looking for is hunger to face really hard problems and excitement to learn as you go. We're just looking for people with different views, different experiences, and different ideas to find the right way to do a reusable rocket next time around.
I think someone who would be a great candidate for Relativity would be someone who enjoys working on complex problems and solving difficult challenges. Having any background with simulation or launch vehicle modeling is always helpful, as well as orbital mechanics or general physics background.
One thing I would suggest for candidates coming from more traditional physics backgrounds is to basically demonstrate that you have the experience of taking the analysis that you've performed on a computer and turning that into actionable insight that you can share with the team and use to help guide design decisions.
Right now the team's about 40. We're looking to double that in the next year or so. We've been growing a lot in the last year, but definitely a lot more to come as we get ready for Terran and all the fun physical challenges there. One of the very unique opportunities here at Relativity is being part of a lot of technical firsts. We printed our first rocket, we're testing it right now. We're about to go through our first launch, then our first customer, and eventually our first re-entry landing of a booster and reuse of it. One thing that people might not know about working in an integrated performance team in a rocket company is that a lot of us didn't have a rocket background when we came in. People come from cars, software development, engineering analysis, planes, missiles. I feel like the opportunity for a really fast pace of learning across a very broad range of technical topics, you can't really find that anywhere else. I think what draws people to Relativity is it's a unique type of physics.
It looks like we are coordinating a new T0 right now that is going to be at 14:35 Eastern. We're awaiting confirmation from Mission Control at the moment, so we're going to continue listening into them for any further updates. All right, and now the T clock is rolling again. We are now 38 minutes away from our new scheduled launch time of 14:35 Eastern. Again, that's 14:35 Eastern, less than 40 minutes away. We're now at T minus 31 minutes, and you might be wondering where we built the launch vehicle that you're seeing on the pad. We currently have 2 manufacturing facilities in Long Beach, California, and today's rocket was printed at our second factory called the Portal, while our new headquarters, named the Wormhole, is home to our 4th generation Stargate printers. This is the 1 million square foot facility we are currently expanding into that will serve as the epicenter for Terran development and production.
Speaking of Terran, Terran 1 is truly a pathfinder to that vehicle. The real opportunity in the market, as proven by our customer contracts. We are actually already ramping up production for this medium to heavy lift reusable vehicle. We have designed it to be capable of 20,000 kilograms to low Earth orbit, or LEO, and we plan to still benefit from the large-scale metal additive manufacturing. One key learning from Terran 1 is with the engines. Let's take a look at this clip of the Aeon thrust chamber assembly test.
All right, so guys, we are T minus. Oh, that's a good static fire. T minus 30 minutes from the launch. Things are looking good now, and what you are seeing in front of you is Aeon 1 static fire test, a horizontal one, not a vertical one. So those both are actually different. Whoa, just look at that purge. That made some funny sounds, but yes, that's how it works.
So what you just saw there was a full power test of the Aeon thrust chamber assembly. I want to give a special
Aeon
shout out
R.
to Jake Shearman, Senior Manager of Combustion Devices, the Propulsion Test Team, and the Stennis test teams for accomplishing that critical milestone. So full power means 258,000 pounds of thrust at sea level. That is what we are designing Aeon engine to. And that is 10 times the capability of the Aeon 1 engine that we have on Terran 1 today. We are already well underway testing components such as a full-scale gas generator test, igniter testing, and as you just saw, that full-scale thrust chamber assembly. We are currently building our integrated engines, and on our Twitter feed, you can actually see an image of our first integrated engine next to a human for perspective on size. We are also completing building of our turbopump assembly, and we're planning to go into full engine tests throughout 2023.
And we're going to test those engines over at the NASA Stennis Space Center in Mississippi, where most of our testing is done. In 2018, we secured the first Commercial Space Launch Act, or CSLA, agreement with NASA Stennis. And we now occupy several operational facilities there, including 4 exclusive use test stands for Terran 1 station.
Okay, so this issue is actually coming in from their end only. Their network connection has some issues, but right now things.
And Aeon engine
Okay.
testing. 2 stands used
We are T minus 28 minutes from the launch.
for Aeon 1 engine tests and Aeon R component tests, and 1 cell for Aeon R engine tests. On top of that, we're building out
Whoa,
an additional
look at that.
150 acres for the Terran R program, and we've already started construction on the new engine test stands. Other structures there will include a full-scale second engine stand, office buildings, and of course an integration hangar. All the structures we're completing out there are built from the ground up on previously unused land. After testing, we ship the components to the launch site. We, of course, have our operational site here at the Cape, but we've also acquired a site in Vandenberg, California, as an additional option for future launches. In 2019, we secured a direct agreement from the U.S. Space Force for Launch Complex 16. And Relativity joins just a few others here as only the 4th company with a currently operational orbital launch site at Cape Canaveral. Both Terran 1 and Terran R will launch from Launch Complex 16. With that, we are now approximately 27 minutes away from launch.
This is so exciting. I hope we continue to move forward. But Just as a reminder, we do not have a customer payload on board, but we do have a memento in the nose cone. We have included our first ever 3D printed piece from our Stargate printer. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you see there is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with a GLHF for good luck, have fun, and our mitosis logo to commemorate this maiden launch.
And from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. Like the first print, Terran 1 is the first step of many towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle. Now we're currently at T-minus 25 minutes. We're going to continue standing by for further updates from Mission Control.
All right. That was an interesting update. We actually got to see some amazing things about what they do, what all facilities they have acquired. So when Vandenberg makes so much sense for this rocket, because most of the time they would need to go to the polar orbits, and if you are going to the polar orbits, it's always beneficial for your rocket to launch from one of the poles. So if it is near the poles, then you would require less delta V to do the same, to achieve the same orbit. So yes, I'm glad that they are working on it. Apart from that, their main goal is to make the Terran R rocket, which is supposed to be a fully reusable rocket, and it would most probably look like this Starship rocket itself, and that will also be 3D printed, that to a bigger rocket. So kudos to them. I hope they 3D print the full tanks there also. We'll have to wait and see how that would look like, but their 4th generation of 3D printers will have to do something for sure. And we don't know the capabilities of the 4th gen of 3D printer, so we'll have to wait and see. So until then, we are having T-minus 23 minutes and 30 seconds remaining. Everything looks fine from here. Hopefully this time we don't have an upper level winds issue, and we shall see this booster looking rocket going to the space.
Situational briefing for pre-go, no-go. All parties be aware the go, no-go poll will be performed in approximately 10 minutes. Primary test objective is a transition into countdown through terminal, startup, and release into flight. Vehicle status, propellant is loaded. We are tracking no additional items for constraints. And while we are still waiting on one final balloon, we are still a go unless that balloon comes back as negative. All assets are standing by for launch. We will do polls in approximately 6 minutes. Stand by all parties.
All right, that looks like good news. So we will be having a poll at around 6 minutes from now.
And you just heard that situational briefing from Clay Walker. The vehicle is very healthy right now, and the only issue that we're tracking is unfortunately the weather. But we are awaiting data, the latest data from our weather balloon, to determine if we can continue and go ahead with our scheduled launch time of 14:35 Eastern.
As we continue to wait, maybe let's do a recap on the Terran 1 architecture, and go ahead and look at this graphic of our Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall and 7.5 feet in diameter. We have 2 stages that are expendable. On the bottom, we have 9 Aeon 1 engines. Each has a thrust capability of about 23,000 pounds at sea level, giving us a max total liftoff of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and as you previously heard, we have thrust vector control actuators, or TVCAs, on the engines that allow us to gimbal during flight. We have completed more than 2,000 engine hot fires as we prepared going into launch today. The Aeon 1 engines are attached to the vehicle through a thrust structure, and above the thrust structure we have WAM printed tanks. Arwa previously shared that this is the wire arc additive manufacturing in-house process that we use. And these tanks hold liquid oxygen on top and liquid natural gas on the bottom. During flight, we pressurize our tanks using an autogenous pressurization system. This means that we tap some propellant from the engines, and this is run through heat exchangers mounted on those engines and converts the liquid propellant into a gaseous state, and we pipe it back to the top to maintain the required tank pressure or ullage pressure. Above the stage 1 tanks, we have a WAM printed interstage, which holds our stage separation mechanisms. This is what we use to separate stage 2 from stage 1 during flight. The stage separation system uses pneumatic pushers. And above the interstage is stage 2, which has a single Aeon vacuum engine. This engine has a thrust capability of more than 25,000 pounds in vacuum and has the capability of multiple restarts. Stage 2 is also WAM printed just like stage 1. And above stage 2 is our WAM printed nose cone, which we just shared about the memento inside of that nose cone. For future missions, we will replace this nose cone with a fairing and also include a fairing separation system. Terran 1 was designed with a payload capacity of 1,250 kilograms to LEO or 900 kilograms to Sun Synchronous Orbit or SSO. All the data from today's launch and Terran 1 development will be fed into Terran R. But note that
RCS checkouts complete.
we're going to go ahead and pause and listen in on mission control for any more updates. Thank you.
Amazing. So there you just heard the summary of this rocket. So if you felt like that was a bit of technical jargon for you, let me just summarize in layman terms. So this is a 2-stage rocket. First stage is powered by 9 Aeon 1 engines running on methalox fuel. So it's kind of an methalox, but not a methalox completely, because it uses LNG, which is nothing but liquid natural gas, having 97% methane and 3% other gases like butane, propane, and all those things. What else? Yes, so the Aeon 1 engine has a gas generator cycle. They are using autogenous pressurization, which means there is no helium bottles to pressurize the fuel tanks.
As of now, it seems like everything is on track, and we're going to perform the go, no-go polls in just a few minutes here. So we're going to stand by to listen into mission control.
All right. So yeah, they would feed the gases of the fuel itself to the fuel tank to pressurize them. So that system has tons of advantages. I won't talk about that right now, but yeah, this is what they do. And in the second stage, the Aeon 1 vacuum optimized engine, again autogenously pressurized, both runs on gas generator power cycle. And yes, there is no payload in this launch, just a nose cone with a dummy ring, which was printed from their first gen of Stargate. So we are waiting for the go no go poll. Right now it is looking good. Hopefully we get to see the go no go poll.
Copy.
There you go. it was supposed to happen at around T minus 16 mark. So we'll have to wait and see whether that poll happens or not. And yes, since you know one thing, that those vents, those that the fuel is being topped off, that we all know, but they need to continuously supply their fuels for this one, because first of all the topping off needs to be done. But one more problem with this rocket is that the LNG which they are using, kind of in that LNG there is 97%
All parties on all nets. This is the go no go
Okay.
for launch. Please provide concurrence to proceed into launch with launch countdown go no go. BC. BC go. BC go. GC1. GC go. GC go. GC2. GC2 go. GC2 go. Ground. Ground go. Ground go. AVI. AVI go. AVI go. FTS.
FTS go.
FTS go. RF. RF go. RF is go. GNC. GNC go. GNC go. Flight software. Flight software go. Flight software's go. Prop 1.
Prop 1 go.
Prop 1's go. Prop 2. Prop 2 go. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 1's go. Fluids 2. Fluids 2 go. Loads. Loads go. Loads is go. Rock.
Ranges go.
Ranges go. OSM.
OSM is go.
OSM is go. RC.
RC go.
RC go. Vehicle.
Vehicle is go.
Vehicles go. CE.
CE's go.
C's go. LC.
LC is go.
LC is go. All parties that reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or a manual abort be necessary, the person calling for a hold or abort should say clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify the LD and the RC on the primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Now let's take a moment to introduce you to our Mission Control team. As you just heard, Clay Walker, Launch Director, John Wiswall, Launch Conductor, James Harris, Chief Engineer, Elijah Escobedo and Zoe Dickert on Vehicle Controls, Brian Batters, Ground Control, Bill Stack, Ground, Joy Mosdell, Range Control. We also have a few notable members of leadership supporting today's launch, and they are also here at Launch Control with us. This includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Zvatek. These are among many, many others who are making today's launch happen. Let's go ahead and take a moment to wait as we get more updates from Mission Control.
Alrighty, guys, we are finally looking good for an on-time liftoff. If nothing happens in between, no range violation or no technical issues, because the weather is holding up now, and hopefully we will get to see this rocket go up to the skies and beyond. So will this rocket make it to the orbit in its maiden launch attempt?
For those curious, you'll
We'll
be
have to
able to
wait and
see
see.
small white pieces falling off the rocket. Not to worry, that is just ice falling off from the frost on the vehicle due to the chilled propellant inside. On the other view, you might have also seen a small flame to the far left of the view, and that is just the flare stack that's used to burn off any flammable gases from propellant loading and venting operations.
Yes, yes, yes. That's a stack which we see in Starship launches also, used to see. Now we don't. They have mitigated that. So initially companies use, because this is a cheap thing to do, dispose of these gases, but
Once again, those
okay.
white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds.
Great. And that is amazing. So finally we are T minus 10 minutes 50 seconds from the
In
launch.
just about 46 seconds here, we will begin our countdown sequence.
That's a cool music. Apt for when the countdown is near, right? T minus 10 minutes and counting. I would like to see a planned trajectory so that I may see it from the other side of the state of Florida. Robert, that is, I mean, you mean to say the launch view area, right? That is not
T-minus
what
10 minutes, countdown sequence has started.
they have released, so you won't be able to see that.
And we're currently at T minus 9 minutes and 45 seconds. In the upcoming minutes, you're going to hear several call outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, as you just heard, and we're currently proceeding with our scheduled launch time.
Okay, this is a backside of the rocket, and you can see the ocean also there, Atlantic Ocean.
In just about 30 seconds, we'll be transitioning stage 1 to helium.
Helium, okay. So you might be wondering, like, why helium? Because they are using autogenous pressure, right? Hopefully the helium may be used to, not so sure whether they are also using helium initially, but helium kind of is used to ignite, this basically is used in the starting up of the engine also. So there is a chicken and egg syndrome which happens during the startup of the engine, and to mitigate that, an external gas is initially supplied to spin the turbines, first of all, and then it sustains. So maybe it's that we have to, I'm not so sure about that, but yeah, that is how it is. And yes, their stream is hell.
And I'm receiving an update here. We
Okay.
just got the data from our latest weather balloon, and we are a go with upper level winds. The weather isn't stopping us today.
Hopefully that is only the case and not a technical issue.
Stage 1 pneumatics have transitioned to helium.
And that means we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight,
for engine chill.
we'll
Yep.
pressurize the tanks with autogenous pressurization.
Yes, that's
That
what I
last call
said.
out was that we're pressurizing the tanks for engine chill.
Yes, that's what I said. There is an initial pressurization which is supposed to happen with the helium. So that is not for the engine itself, that is for the tanks. So yes, there were two cases which I told you. So one of them is correct. And yeah, initially they will be using helium for
Now
here,
getting into the business
but not
end of today's
afterwards.
countdown. Let's take a moment to walk through the launch timeline.
At T minus 3 minutes, the transporter erector, or that black truss structure, will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. Then at T minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. And we then go into final flight termination checks
To igniters and flight targets.
and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed Aeon 1 engines, so you'll see the flames beneath the rocket at that point. And at T0,
Whoa.
we will have liftoff.
Engine chill.
Shortly after that, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program, and at T plus 80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff, or MECO. This is when the stage 1 engines will shut off. This will be followed shortly by stage separation and ignition of the Aeon vacuum engine. Second stage will burn for a little under 5 minutes. And then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for today's first launch. We'll go ahead and continue listening in.
Just look at that. That engine chill is something. Wow.
Currently priming the igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across the glow plug.
Okay. So they use hydrogen and oxygen for their ignition. Well, that is interesting. T minus
Stage
4
1
minutes,
igniters priming in.
20 seconds remaining. Everything is looking good. But
As a reminder, GLHF is our maiden launch, so while a nominal flight would have Terran 1 reach orbit today, our primary goal is to learn as much as we can and demonstrate the product concept. A major milestone would be to have Terran 1 make it through max Q, the point
Yep.
of maximum dynamic
as
pressure.
I said, this is a 3D printed rocket, so they actually need to test the structural integrity of the 3D printed material. So the max Q, which is kind of a normal thing for other rockets, will be an integral part for this one. So this one may not
You'll
reach
now
the
see
orbit,
those
but
cradle arms are slowly starting to release stage 2 at the top there so that the strong back can retract.
if it passes max Q, that would actually make it make this rocket you know, a proof of concept for the Terran R1 that rockets can be 3D printed.
Over the next minute and a half, we'll be performing the final thrust vector control health checks on both stages before liftoff. You'll be able to see the engines gimbaling or tilting if we're in that engine view. There we go.
Oh, look at that. This view is so amazing. I just love this one. You can see the engine gimbals, the engine chill. Wow. But if they are pumping in the hydrogen and oxygen for the engine chill, that is very much flammable. I don't know how they will mitigate those flammable gases, because in other launches we see the rofies actually doing the part to, you see the space shuttle launch, the SLS launch, there are some sparkles which is ignited before the launch. Not so sure what would happen here, but they need to mitigate those flammable gases. And now T minus 2 minutes, 20 seconds remaining. Everything is going as per the plan. Weather is green, range holding up, and wow, just look at that.
As we approach T minus 2 minutes, what you're looking at on your screen is a vehicle that is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final range status.
Things are going to happen soon. T minus 1 minute 40 seconds remaining. I am so like very much excited for every launch. This much only. So T minus 1 minute 30 seconds. Those engine noises, wow. Not engine noises, but rocket noises.
Hold. Is the MIFCO will hold due to a foul range?
Foul range, no!
You heard that call out.
Oh,
Someone
God.
is calling a hold due to the range. We're going to stand by for updates.
Dude! I was so excited. Who is there on the boat right now? I don't understand when those guidelines are issued. That should be followed.
Appears that there may be a vessel within our clear radius. We're going to stand by to hear confirmation from the range.
And guys, again, as I said, this is a big problem for this rocket. The time which they have holded for right now, this is a very big problem for this rocket, because not so sure whether like how the countdown would look like for this rocket, but if they can reset it before offloading and reloading the propellants, then it's all good. But if they had to reload the propellants, then there's a problem, because they are using liquid natural gas, and that is having some 3% of other gases also. So when they offload the propellants, store it somewhere, the methane being highly what should I say, they have lower ignition temperature, lower boiling temperature, boils off firstly, reducing the methane concentration in the propellant itself. So that means
Just got confirmation there is a boat in the range. We're going to stand by to see if they can clear the boat from our radius.
yeah, so that would mean the fuel composition would be affected with offloading and reloading. So that is not what they should do. Yes, they can continue to top off their fuel if that is possible, if there is some thing which they have in the countdown. Otherwise, dude, why? I was so hopeful that yes, this is launching for sure. Now they will have to recycle the countdown, and we'll have to wait and see like what actually happens. I haven't seen such range violations anywhere. Whenever a rocket launches from Florida, there are some certain range violations. For some reason, I don't know. And yes, they are actually they need to fix their live stream, having some internet issues with them. But whoa, those boats, well.
Once again, just to clarify, our vehicle is healthy and all systems appear to be performing nominal. We just got to go for the weather for upper level winds, but unfortunately there is currently a boat in the range, so we're just awaiting confirmation to see if they can clear that boat in time and get it out of our radius.
So it happened at T minus 70 seconds, around T minus 70 seconds. So if it would, the countdown would have gone under that, no, then at T minus 70 seconds, the actual countdown is controlled by the rocket itself. So if it goes below that, you can see it is actually the countdown actually holded at T minus 70 seconds itself. So that was a manual hold. So under that, if it goes below that, then it is controlled mostly by the computer. Then the range, I don't know how they would have accounted for the range, but yes, since they have stopped it before that, maybe they will be able to recycle it. Let's hope that happens. and we get to see this rocket go off. Obviously they will need to recycle the countdown timer, and again they see now what would happen is they need to again look for, first of all, obviously that that stupid boat needs to go away. Once the range is cleared, they will need to issue a new T0. Once that is issued, they need to do some simulations of the orbital mechanics, or like how the flight parameters, the flight software which they have designed. They need to update that and then go for some simulations, whether that simulation
Countdown net is the LD. We got a hold called prior to terminal count. Hold gating items have been cleared. We are adjusting for a new T0 time. We'll hold the clock for terminal count until we pick up the count.
There you go. So finally the boat is cleared for sure. That's a relief.
All right, now we are just confirming a new launch time. All items that were blocking us and giving us a red range have now been cleared out. So we're going to await that updated launch time and then update the T clock above as necessary.
All right. The marshals must have done their job really quickly, so that is good. But yeah, finally the range is clear. They will issue a new T0. So now what they are doing is they will first of all determine what could be the new T0, then load the flight software according to that, run some simulations whether those the flight software which they have loaded is correct.
And the clock is about to resume just shortly here. They are coordinating that new T0. We're very excited to get this thing going.
Countdown net. T-clock should pick up in 60 seconds.
60 seconds.
60 seconds? What?
We have confirmed our new T0 is going to be 14:42 Eastern. Once again, that's 14:42. We'll see the T clock rolling in just a moment here.
Wow, that is something cool. And so their recycle time is kind of we'll have to wait and see how that would look like, but they're recycle, so they are not going into that traditional path of running the simulations. So they are not loading a new software.
T-clock's rolling. Terminal count.
Alrighty. What happened? T-minus 60 seconds remaining.
T-minus 60. GC with the count.
Alright. Whoa. T-minus 60 seconds remaining. Let's go for the launch. Oh, look at that. Rocket
LD,
bumping up.
Go for launch.
Go for the launch.
LD is go for launch.
And we just got that final go for launch from our launch director. We are now just about...
Range green.
Range is green. We're now about 30 seconds away from the moment that we've all worked so hard for our first launch. We've had a lot of fun with you, Terran 1. Good luck.
T-minus 20,
And here we
19,
go.
18, 17, 16, 15, 14, 13, 12, 11, 10.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Uh-oh. Well, it's still standing. F's in the chat, guys. F's in the chat. That was an hot fire abort. Whoa, that was so cool. That engine cam was so
As
cool.
you can see, we had ignition of our engines, but the T clock did hold at T0. We're going to stand by for updates.
Now this is not gonna recycle for sure. Hopefully means not so sure. They are not following traditional paths, so we may not know. But what happens traditionally is whenever there is a hot fire abort, you rarely see another attempt. They'll have to see like what actually happened, because whenever there is a abort at T0, that means there is some serious mechanical issues which can't be like um, um, been fixed with just a restart of something. So have to wait and see. But whoa, boy, that was amazing. That engine camera and then that engine ignition, that looked so sick. Oh, and they literally picked up the countdown from where they left. Means they did not have, see, they did not recycle or anything, because uh, I think they need to follow this strategy itself, because they can't recycle like normal rockets do, offload, reload. I told you the reason. So yes, that is an interesting thing which they did. It was all like, okay, another hold, we have to wait for some more time, and then instantly T minus 10 60 seconds remaining. And then at T0 we saw an hot fire abort. Hot fire abort mostly is because of some engine issues, but here we can see that the engine actually ignited. So and but it may what let me just explain you what could have happened right now. Still, I don't have any much very much informations to make any comment on it, but usually when there is a hot fire abort and we see an engine ignition almost coming to like full thrust, that means that the engine did not actually reach the full thrust. Okay, it did ignite, did the turbo pumps actually ran, we got to see the uh, um, you can see the water is also there, the ignition and vehicle, the engines coming to full thrust, but they may not have come to full thrust, and because of that the computer decided, nope, not today, we are scrubbing it. So
All right, I'm hearing from Mission Control that we're currently assessing vehicle health to confirm if we can do a recycle today and try this thing one more time.
Yes, let's see whether they can. I would be like really very amazed that after an hot fire abort, if they will be able to recycle it again, because now they have used some propellants. Okay, they will need to load new fuel into it. So let's see how does that work, because right now so they are doing that only, obviously. They will need to reload the fuel, not reload actually, yes, they will need to load the fuel, new fuel into it, both the liquid oxygen as well as the LNG, and then we'll have to see like what happened. Because this is like, when the engine ignites, and there are so many factors which comes into play. Most of the time it is also like, you don't have enough what should I say, ignition fluid left, right? Then what would you do? So if they have some sort of ground supporting engine ignition fluid, then engine igniter, then it's all right. Okay, and hopefully they are using that only, because in most of the cases when the okay, most of the cases for the first stage, the igniter basically, igniter is stored in the ground support equipments only, to reduce the weight, to reduce the complexity, because obviously the first stage does not have to reignite until unless it's a Falcon 9, obviously. But so yeah, that's what happened. So if that is the case here, then igniter won't be a problem. And yes, they are supplying that hydrogen and oxygen from somewhere else only, not from the rocket. So yes, they should be able to reignite it. But again, the vehicle health is a problem here. We'll have to wait and see whether engines are good. Hot fire abort is not a good sign any day. It almost always means that they are not going again for a launch. But startups are bold. Okay.
Announcement on countdown net. This is the LD. We aborted terminal count on a launch commit criteria violation at T-minus 0.5 seconds prior to liftoff. We're safing the vehicle and assessing recycle opportunities.
Okay, so they are actually considering a recycle. Maybe they are assessing the situation.
As you
So
heard once again, we had a violation with our launch commit criteria, which is why we had an abort shortly before liftoff. The team is continuing to assess vehicle health to confirm if we can have a recycle today.
Ray should have been a Falcon 9. Well, it's a mini Falcon 9. Ray has that those 9 engines, um, and once this is successful and they move to Terran R, then that is definitely a mini Starship, because that's fully reusable, and the second stage has wings. So yeah. uh, Mars 2028 says, could the highly unusual hydrogen ignition system have been a problem? No, I don't think so, because ignition system is not a problem at all. We just saw the ignition of the engine, so that went nominally. What could have been a problem is the operation of the engine. Okay, most probably the engine might not have come to full thrust, the thrust which is required, or there might be some other issues like the combustion chamber pressure, whether was it optimal, or whether the everything, like the working of the engine itself, was like optimal or not. Obviously it was not. That's why the abort happened. There could be so many factors with it. We'll have to wait and see. They only know, they have the data what actually went wrong with that. But we can only wait and see if we can have any update also. But I don't think so, unless they pull out a rabbit from somewhere else. I don't know, but very highly unlikely. And you can see those flare stack being very rapid right now, because it's kind of burning off a lot of um, not needed gases, which is causing an issue. You can see those being vented out also from the fuel tank, fuel lines. So there's that. So the vent lines, the thing which you are seeing in front of the rocket, in beside the rocket, is clearing up the vent lines, the pipelines of the rocket itself, and the flare stack is taking care of all other pipelines and residual gases. So that thing happened in sync. So it's good to assume those work in sync only. But well, we'll have to wait. It literally aborted at T minus 0.5 seconds.
As a
Dude.
reminder, we're currently at 14:50 Eastern time, and our launch window is open until 1600 Eastern. So our teams are currently assessing any recycle opportunities that we have during this time.
Yep, Labrat, you have seen those Starship launches, Starship static fires, right? Yes, that's a detanking operation which is going on. So, but here, whether the detank actually properly happens or not, because it's an LNG, that we don't know whether they actually detank full fuel, or whether they just top it off. This rocket is having some issues. At least she's standing right now on the pad. But we still have some time, since how much time is left now in the launch window. So let me check. So it still has like 1 hour left in the launch window. So if they think that the issue can be resolved by doing some things which they can do from remotely, basically, so then it's all right, then they will go. But otherwise,
You'll see an occasional cloud coming out of the transporter erector or the black truss structure there. That is just because we're creeping our propellant topped in case we can reattempt a launch before the end of the window today at 4 p.m. Eastern.
There you go. There's the clarification for you all. I really like that in this stream the commentators actually are explaining each and every bit which they can to let people know what actually is happening. And you can now see that truss structure, the black truss structure is holding the rocket again, which means now it shall go into propellant loading stage once again. So it is actually connected to the rocket now again. So let's see what happens. But yeah. Happy Toby Bruno noises. Yes, kind of. Rocket has commitment issues. Don't you think like everyone nowadays has? So the rocket is no exception.
As you can see, the T clock rolled back. We are still working on a recycle, so we'll keep you updated as soon as we have confirmation.
Minus 45 minutes. There will be a recycle then 45 minutes. Okay, so that means they will need to recycle in how much more time? 21 minutes from now. 21 minutes from now, that timer should continue again. If that does not happen, then they are out of their launch window. So if it's a 45-minute launch, so this is a total recycle now. So they will need to offload the propellants totally. So now they must be having the amount of what should I say, new propellant in their stores so that they can again reload them. The propellant storing is also a problem in these kind of launches, especially LNG, because you need to store those at a like particular temperature only, right? The temperature in which they stay liquid, otherwise those propellant would boil off. And as she said, in LNG the methane has the lowest boiling point, so it will boil off quickly and the concentration would change. You don't want that to happen at all. So yes, they need to store those propellants properly itself. Properly means properly. They can't mess that up, otherwise the fuel composition would change. They are actually playing with because they are not using like rocket grade kerosene, which has like almost very highly purified form of kerosene. Then the hydrogen, which is nothing but hydrogen. They are playing with LNG, which is 97% methane, 3% other gases, and that 97% methane can go to 95, 96, and then the composition changes, and then the stoichiometry ratio changes, and all those things, the fuel thrust, ISP, everything, calculation, all gets messed up, and you don't want that. So yes, it's always better to eliminate that issue at the very base end, which is storing the liquid fuel. So hopefully they are doing that only, so we'll have to wait and see like how that pans out. So it's like, yeah, it will end soon in just 16 17 minutes, 18 minutes basically. They will need to resume the countdown, otherwise they will miss the launch window. Let me see if we have any other update. I'll update you if I do. Hey Wildflower, welcome to the stream. Yes, you didn't miss it, but obviously your notification system again messed up, I guess. Okay. But we are looking to see whether the heat shields are printed. Not, don't think so, Lars Chrome. So what? See, 85% of this rocket, 85% of this rocket by mass is 3D printed. So all those things like rubber seals, rubber gaskets, the computer chips, and all other things which require proper manufacturing are not 3D printed. But the metallic parts, all those must be like 3D printed, obviously. Wirings and all those things, that can't be 3D printed, right? So the PCB is there, but that is not 3D printing. So yeah, those things are manufactured, but 85% by mass, this is 3D printed totally. They now have like 5 minutes remaining, until unless if they don't start, then it would not happen today. Wait for 5 more minutes and we shall see if this goes for a ride or not today. Obviously, if talking about backup launches, launch windows, well, they have tomorrow. So, and weather conditions are even good, are even better than today. So today we had like 10% violations of weather conditions. Tomorrow it will be just 5%. So 95% go for the launch. But let's see if this goes for a ride today or tomorrow it will be.
All right, the T clock is rolling
Whoa!
again, everyone. We just have an updated launch time of 15:55
Dude, that's
Eastern. Once again, 15:55 Eastern in just under 44 minutes. We're gonna keep going.
okay. Well. This is the first time that I am seeing. Well, they are definitely bold. I have to give it to them. First time in my history of launches that I am seeing hot fire abort getting a launch T0 again. Wow, this is awesome. Let me just update the timer here also. I told you they need to restart it soon, so still they have like 5 minute window or so. If they can hold for like 5 minutes or so if something bad happens, but hopefully that does not happen and we get to see this launch today. T minus 43 minutes and counting things. Let's see if this they will have to. I am hopeful that they actually tell us like what happened there and what did they do to resolve it. That was quick. So this is like what I like about startups, you know, they don't play by the rules, they don't go by the book, they make their own rules, and they are bold and want to do things which nobody has ever done. They want to risk everything, and yes, they are doing that. And until unless you risk, you won't get rewarded. High risk, high reward. So hopefully they and actually, you know, guys, they actually have to risk it if it can be risked at all, because LNG is a big problem for them. So they can't just you know, store that extra LNG which they have until tomorrow. So yeah, they'll have to try it, and they are going for it today, and I am happy about it. Like finally this is happening again. So 15:55 Eastern, that's the launch time. We are looking and hopefully this time there is no boat, no problem from the weather, and the rocket itself, the computer, this time does not, hopefully does not aborts at T minus 0.5 seconds. So guys, if you have just joined in, let me just tell you that we are we had a launch attempt, two launch attempt to be precise. So in the first launch attempt, for today I'm talking about, in the first launch attempt there was a wayward boat that was cleared like really very quickly, and then the countdown got resumed, and then it went on till T minus 0.5 seconds, like literal 0.5 seconds, and then it was aborted by the computer itself. We don't know what actually happened there, but now they have recycled it. The clock is set back to t minus 40 minutes and counting, which you can see right now. And they are looking in for today's launch itself. This is the first time that I am seeing a company doing a recycle like this after a hot fire abort. So kudos to them. And also, what was I saying? Yes, talking about this rocket, this is a completely new rocket, and 85% by mass is 3D printed. So at max Q, look out for this rocket at max Q, because things can happen at max Q itself. So let's see. Again and hold. No! Now that's a problem. Whoa, what was that? What was that? Have they updated their... I think they have. I need to update it in my timer also. So now they have eaten up that very last 5 minutes which was remaining in the launch window. So now they can't hold at all. If they hold, then that's it. That's it for the today.
Update from our engineers and mission control. We are updating the T0 time to 1600 Eastern. Once again, that is 1600 Eastern. T clock is rolling.
Cool. No worries. Now they have eaten up their launch window completely. Now this should, if a hold happens, that's it. No more launch today. Okay. But if it does not, this clock will be rolling in, and hopefully this time there is no boats. Please, there are no boats this time. Okay. Let me see if I have any other update for you. If I do, I'll share it with you.
For those of you that are tuning in today, we're going to take a moment again to introduce ourselves. My name is Rachelle Aniceto. I am the Chief of Staff for the Vehicle Architecture and Technology team.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch here at Relativity Space. Now, ahead of Terran 1's liftoff, we invited some of the most influential voices in the space industry to curate some questions from you all on Twitter about our journey to launch. We appreciate the time that Michael Sheets, space reporter at CNBC, Eric Berger, senior space editor at Ars Technica, and Tim Dodd, the everyday astronaut, took to answer your questions. Let's take a look.
Oh, nice.
This question comes off of Twitter from Danny Stover. Many launch companies fail their first attempt. Will Terran 1 reach the same fate? What makes Relativity's approach different? I want to hear, Michael, what do you have for that one?
Many companies failing their first launch attempt is, I think, a great example of the high risk aspect of the development process. And I think that's one thing a lot of people need to keep in mind is there's along the way to development, even before launch, there's all these milestones that you're trying to get through, including, as we've seen recently, static fire. So you pass those milestones, you get more data. As you move closer and closer, the end goal is, can we not just get into space, not just get into orbit, but deliver into the targeted orbit, get to the place we want to actually be? And I think a nice analogy of it is like ordering an Uber. You want an Uber that's going to get you the closest to your destination, ideally your front door. But if your Uber is dropping you off, a couple miles away, you're probably not going to continue, using the app anymore because you're going to try to go with a competitor who's actually getting into that ideal orbit. So will it make its first attempt is that open question. And I think I really want to stress the development side of where the company is, because people see failure at kind of any stage and they go, oh, this is a wash. But it's really important to understand that ultimate goal of an intentional specific orbit.
I'll answer the question a little bit more bluntly. I do think Relativity probably will fail on their first launch attempt. If you look back at no new space company has ever reached orbit on their first flight attempt. You had Rocket Lab fail, SpaceX failed on their first attempt, Virgin Orbit failed, Firefly failed, ABL failed. And so, it's the odds are against them, and more credit to them if they succeed. And I also think that the 3D printed nature of the structure is a big test. Are you going to be able to see that get through max Q? And then there's some more complex elements on the Terran 1 rocket that you might see in a more traditionally developed launch vehicle. And so I think seeing a nominal first stage performance would be a pretty big win for Relativity. And I'd love to see them get to orbit on their first time out. I just think historically the odds are pretty long against it.
Yeah, I'm definitely with Eric there. I realized just recently that, the Pegasus, when it first launched, was one of the only rockets to successfully make it to orbit on its first launch. So, that was definitely not by any means considered new space by today's standards. But realistically, like Eric said, the odds of being completely successful on the first round is statistically about zero. So I'm just excited to see if they can get through the first big milestone. If they can, make it through max Q, if they can see stage separation. Each staging event is definitely one of those big unknowns until you do it for the first time. Can you light your upper stage engine? Can you, deploy your fairing? Can you eventually, if you get to deploying a spacecraft from, on orbit, that's the ultimate milestone, of course. But yeah, there's a lot of things between there and leaving the ground. So yeah, time will tell.
I mean, I think only of the companies that we talked about outside of Pegasus, and that was Orbital Sciences, and of course that was a solid fueled rocket, and most of which was not developed in-house like the commercial space companies of today. But of the companies we talked about, only Rocket Lab got to like a second stage engine ignition and flight, right, on their first mission.
Yeah.
21st century wise, that's definitely true. And I think another way to tackle this question is defining failure, because when you talk about many companies fail their first attempt, you need to understand the multi-step process of a rocket launch. And I think that's another important aspect where, depending on how far they get towards their ultimate goal, it will categorize whether this is a learning experience from a failure standpoint, or this has a lot more to build upon. And every step that they complete during the launch is another check mark towards success.
Yeah, absolutely.
This next question comes from Han Tronics. With the capability of 3D rocket printing, will we see a day when rocket engines are a part of the ship structure such that their major components won't need to be removed, inspected, or replaced after every launch? I don't remove my engine in the car every 1,000 miles.
I think there's always going to need to be some kind of repairability and separateness of the components of the structure of the vehicle and the engines. I mean, there's just an inherent, physical moving parts. You have bearings, you have valves, you have components that just would need to be inspected on any vehicle. And if you completely integrate that into the structure to the point of not being able to remove and service it, you just really, you really limit yourself. Now, if you're talking about an expendable launch vehicle, there is the potential that integrating it could actually add potentially some reliability or simplicity or mass saving. So it depends on your overall goal. If you're talking about a reusable vehicle that you're flying over and over and over, completely integrating it to the point of not being able to even remove and service it is probably not the best idea, in my opinion.
I would just say that, this is an impossible question to answer now, because we have to see if 3D printed rockets are capable of flying. And that's the great thing. What I love about the launch industry today is you've got all these companies trying different things, right? You've got ABL out there trying to basically build a miniature Falcon 9 as simple as possible, a modular approach, ship it and shoot it from a launch pad. You have, Virgin Orbit trying air launch. You had Astra trying to build the cheapest, perhaps less reliable rocket, and you got Relativity doing additive manufacturing. And so it's great to see all of these different approaches, because we're going to try them all out, and it takes a real world test, I think, to get the right answer ultimately.
I'll do this one. This one comes from Kyle A. Mabe asking, what other markets in the space sector or beyond do you see Stargate technology being applied in? I kind of mentioned it earlier. I would love to see, large scale additive manufacturing be used for, automobile prototyping, race car prototyping, especially. Oh my God, like the Formula One world, where every year the cars have new restrictions and new rules and a new, set of rules to have to engineer by. Being able to at scale develop stuff with a 3D printer makes all the sense in the world. So I think that's a pretty no-brainer, would be the automotive industry.
I think there certainly are potential other market use cases, but additive manufacturing, obviously predated Relativity, and they're trying to apply it in this really significant way with such enormous structures. And I think that's the fascinating aspect, is you try out the technology behind the rocket in such a extreme use case, where then other sectors can look, where can we apply this? Where can we iterate faster by implementing printing these as solid entire structures, as opposed to different pieces that you put into, whether it's for shipping or other large industrial components. You can see the kind of downstream effects of basically a demonstration of, hey, we can build a rocket with this type of technology. What else can't we build?
I think Michael's exactly right. There's been talk about Relativity since it was, almost since it was founded. Is this a launch company, or is this a 3D printing company? I think, that once they sort of wrap their hands around spaceflight, they're going to be taking this technology into other areas, and we don't really know what those are. It'd be interesting to find out. Just for me personally, one of the big issues that we've seen in this country and around the world has been housing issues. And so I don't know if 3D printing these large structures could be applied to housing units or things like that. But it's going to be fun to find out where this technology goes.
That was a great video answering some of your questions on Twitter. Now we are at T minus less than 30 minutes from our launch with our updated launch T0 time of 4 o'clock p.m. Eastern. So that is 1600 Eastern. We're currently going to stand by from an update from Mission Control in the next few minutes.
Alrighty, those updates were actually really good, to be honest. Um, well, we got to know about certain things like how those things work. Stargate, Wildflower. Well, Stargate is not a rocket. That's a name of their 3D printer. So this rocket is actually 3D printed, right? 85% by mass. So the Stargate is kind of a very big 3D printer for them. So now this rocket is printed from the third generation of their 3D printer. Now they are moving on for their fourth generation. So there's that. But right now, other than that, we got to hear some other questions which were amazing actually. And most importantly, one of those was like you can see the stats, right? None of the companies other than Pegasus have been successful in the first launch, and Pegasus was like all solid rocket, and um, solids are kind of easier, relatively easier to manufacture as well as operate. Yeah, not control but operate. Yeah, so we'll have to wait and see, and only Rocket Lab, as he said, was able to actually go to their second engine ignition, which was amazing. And now this is where we are standing. Will relativity space will be able to be successful, like 100% successful in the maiden flight? Well, that is yet to be seen. That is yet to be seen. Negative Nelly. Well, see, if that countdown holds for whatever reason now, then it is not going for sure. But if it does not, now it seems like they are being desperate, okay, for some reason. Not because they not actually like desperate as in fully desperate, like 100% desperate. No, they are risking it. That's what I am saying it. They are confident, obviously, but it's like, in rockets, what they do is they need to be double sure. They are not being double sure. They are going like, okay, first time sure, this gonna work. Okay, let's go. Because they will be having some issues with the propellant handling then. So hopefully this launches today. We'll get to see, because startups are known for the bold moves which we saw just now. So hopefully this launches today and we get to see a beautiful flight. Still, again saying, there has been no liquid fuel rocket which has been successful in the first flight itself, fully successful. Will Terran 1 rocket from Relativity Space be the one? We have to find that out. Hey, Fly in the Bug, thank you so much for that. Yeah, I do remember those nights. Oh God, that was some journey. But I really want to do some more things for the channel. But I go in morning like 9 a.m. in the morning and come at like 11 p.m. in the night. I really just don't get any time, other than, see, my schedule looks like this only. 9 a.m. I go to work, 11 p.m. I come back. So this time any launch happens, that would be like very rarely I would be able to stream those things. But uh, uh, thankfully most of the launches happen during the night only. So when I come home to the night, I if there is a launch stream, then I just do all my launch research and everything, makes schedule the stream, and then sleep for like 1 hour or so, and then come again for the streaming. it really, I'm telling you the truth. Okay, now I'm telling you the truth. When I wake up with like just 1 hour of sleep or something like that, now my stomach hurts. I seriously face so much health issues at that point of time, because um, my stomach actually becomes really very acidic at that point. Okay, and it really hurts. I can't even and it feels like, no, just go to the bed and sleep. But I have to come here and stream. That's like, no, I have to do it. So I just go and like come here. But seriously, whenever I stream late in the night, I am I'm like in pain sometimes, most of the times. But then also it's all right. It's part of the thing. So all right. But yeah, this is what happens. So sometimes like it's like 1 hour, after 1 hour sleep only, I'll have to stream the launch, and then again go back to bed. Sometimes that also does not happen. Going back to the bed for like 1 or 2 hours again, and then going back to the work again and coming back 11 p.m. So I really have to do so much more for this channel, but I can't because of my schedule. So in the weekends I try to relax. I try to sometimes take my own me time, but now I'll have to do certain things on the weekend itself. So I'll need to utilize my weekends more for these kind of stuff. So yeah. No, I know what happens. What happens, Wildflower? Actually, my gut hurts because at that point of time during that sleep, no, my stomach is kind of acidic because it's digesting the food and all. I kind of because I come at 11 or so, na, I have my dinner late at night, like 12 or 1 or something like that. So because of that, na, since I have my dinner late, my stomach is kind of acidic if I don't sleep. It's acidic. It's a normal process. Okay, it's acidic for everyone, but during sleep it becomes more acidic because of my late night dinner. So because of that, if I wake up, I can feel that acid. Otherwise, I don't. In the morning, it's all right, but during that time, it happens. So yeah. Yeah, I know, I understand that, but it's like, it is not a, like, what should I say, a major problem, because I know this is the process. This is just a lifestyle for me. Okay, because I eat my dinner very late, this happens. So there is no solution for it as such. I can just only suppress those things. Otherwise, no. I know this will happen. This will happen for anyone. But yeah. If I eat my dinner at time like 9 p.m. or 10 p.m. or something like that, then that does not happen. It's all because I eat dinner late. All right. We are T-minus 20 minutes from the launch. And we shall see that engine chill soon. We did not get that launch situational launch analysis from that guy, which used to happen at T-minus 24 minutes. Hopefully everything is all right, but at around T-minus 15 minutes or so, we shall hear that go no-go poll, and if that is all good, we shall see the launch today. Music is sick, I must say that. Actually guys, if you want these music, this playlist, right, Relativity Space have released their Spotify playlist on the Twitter. So if you want, if you like the songs which you are hearing, then go check out that playlist. I have saved that playlist because those tunes are sick, I must say that. T-minus 9, under 19 minutes now.
The go, no-go polling from Mission Control is coming up here in just a couple of minutes, around T-minus 16 minutes. We're going to stand by and continue listening in, awaiting that poll.
Bad German house music, okay. Well, it's just like, maybe it's a taste of the music. Younger generation may like this or not, I don't know. Actually, you know why this music is a bit different? Because this has some beats in it. I mean, those beats are not like relaxing kind of, because other, like in Electron launches, you know, those beats which are played are kind of when I listen to them, I kind of feel sleepy sometimes. But that is not happening with these. So yeah, kudos to them. Okay, you can see now the pressure, sorry, the feed lines are getting cleared. Those are being so they are really getting in for that. Things are looking good. They are getting in for that launch attempt now. Will this launch? Because if I remember correctly, something similar, not actually, you know, ignition happened, but something similar happened with that Astra launch. Yeah, Astra launch, where the abort happened just before the ignition, like T-minus 2 seconds or something, and then they recycled it, and then they went for the launch. But at that day only, that naughty Astra rocket did that maneuver, the X maneuver, right? If you remember, it went to the right side. So will we see something similar? Hopefully not. That should not happen with any rocket like that, but anything can happen. This is the first launch of this rocket, you know. Let's see. Dude, you haven't slept last night. You haven't studied. Oh, I've been in that situation. Okay. You know, during my college days, what used to happen? I used to give exam without sleeping. I literally used to study the whole night, literally whole night. I don't sleep. I used to go to my college at like 10 a.m. or so. I give my exam, and then 12 a.m. or something like that, I used to get free, come back and then sleep. Then wake up at 6 p.m. or 7 p.m. study for another exam, which was supposed to happen the next day itself. Repeat that cycle of not sleeping till the end of like tomorrow morning, give the exam. So yes, I have been in that situation. You can totally understand that. Which exam do you have on Sunday though? Is it like competitive exam or something? All right, T minus. We should be hearing that go no go poll really very soon. That is imminent actually. We'll see. hopefully they are making sure that they can go forward with the go no go poll, and we shall hear that. But yes, the rocket is standing on the pad, things are looking great, and we shall see this rocket fly this time. Let's see. Oh yeah, okay, cool, understood.
All parties on nets. This is the go no go poll for launch. Please provide concurrence to proceeding the launch operations with go no go. GC go. GNC. Lights off where? Prop 1. Prop 2. Fluids 1. Fluids 2. Loads. Rock.
Ranges go.
OSM. RC.
RC go.
Vehicle. CE.
Are we like
LC.
not
LC go.
hearing them?
All parties report go for launch countdown.
Yeah, we did not hear them actually. But yes,
All
we
right,
are.
our team is being relentless here. We are not giving up, and we're going to give this one more shot with an instantaneous window at 1400 Eastern. As you heard, all parties have reported they are go for launch.
And just a reminder, 1600 for that launch. And as we continue to wait, let's remind you what we have inside of our nose cone. So we don't have a customer payload on board, but we do have our special memento, which is our first ever 3D printed piece from our Stargate printer. As we mentioned before, it was a failed print, but this is just special for us as we get to this moment. As a reminder, that piece is about 6.5 inches in diameter and weighs about 3 pounds, and it is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we added a machined centerpiece with GLHF and our mitosis logo to commemorate this maiden launch. We'll go ahead and tune back in to mission control and wait as we get closer and closer to launch.
Righty. Well, we are T minus 11 minutes from the launch, and this rocket right now you can actually see those ice crystals on the launcher, right? If this would have been the Electron rocket, all black, those structures would have been white, and you can see that there is no fairing, literally no fairing. It feels like a booster part, right? The Falcon 9 booster part with that nose cone. But yes, this is just this is also a rocket. The flight dynamics are different for this one because the fairing is not there, but obviously they would have taken that into account. And we are having an instantaneous window. We are looking good for the launch, and let's see what happens. I'm very excited for this one, finally. You don't need to wildflower because whatever weight the frost is actually adding, that is shredded off when the rocket lifts off because of the intense vibrations and you know, the aerodynamics. The ice can't take it.
T minus 10 minutes. Countdown sequence has started.
And you heard that call out. We're currently at under T minus 10 minutes. And in the upcoming minutes, once again, you're going to hear several call outs from Mission Control as we go through the final pre-launch procedural steps, including priming of the igniters, final engine checkouts, transporter erection retraction, and getting that final go for launch for this attempt. Again, we're now pressing the tanks
Going to flight targets.
to flight pressures, as you just heard, and we're currently proceeding with our time of 1600 Eastern. This will be our last attempt for today, and it is an instantaneous launch window.
All right, guys, this is finally happening. To all the guys just joining in, we have what you are seeing in front of you is a Terran 1 rocket, and it is kind of a mini Falcon 9, you can say. Is having 9 engines, Aeon 1 engines, running on methalox fuel, not exactly methalox, it's an LNG, 97% methane, 3% other gases, but yes, it is using methane and liquid oxygen. So the plume which you see will be kind of purple in color, which you expect from a starship. Isn't it cool? And if this reaches orbit, then this will be the world's first rocket to reach the orbit.
Stage 1 will be transitioning to helium shortly.
To reach the orbit, which is powered by a methalox engine. So that would be a feat. And if this reaches orbit, then also it will be a first orbit.
Once again, that means we're pressurizing the propellant tanks to flight pressures with helium. And as a reminder, during flight, we'll be pressurizing using autogenous pressurization.
Yeah. Guys,
tanks are pressing for engine chill.
We shall see that engine chill happening with the help with gaseous hydrogen, gaseous oxygen. So engine chill happens with that, apparently. And yeah, guys, there you go. We can see the engine chill. It looks amazing. And this camera, we actually get to see this camera during the launch. So that is amazing for sure. And I am really very excited for this one.
Getting into the business end, let's remind you about our launch timeline. Arwa, take it away.
So again, at T-minus 3 minutes, the transporter erector, or the black truss structure behind the vehicle, is going to retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will of course be on internal power. At T-minus 70 seconds,
Stage 2 igniters to flight targets.
The vehicle will go into terminal count, and this is again when the vehicle's internal flight computer takes control of the countdown. We'll then go into flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6, we're gonna see that ignition one more time of those 9 Aeon 1 engines. So you'll see the flames, the blue fire, I should say, beneath the rocket.
Stage 2 igniters priming in.
And at T0, we'll have liftoff. At T plus 2 seconds, the strong back is going to throw back to remove the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program. And then at T plus 80 seconds, we're going to reach max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff. That is where the stage 1 engines will shut off, and it will be followed shortly by stage separation and Aeon vacuum engine ignition. Our second stage will burn for a little under 5 minutes. Then at approximately T plus 463 seconds, we'll get to second engine cutoff when that Aeon vacuum engine will shut off. And as a reminder, we do not have a fairing or any payload deployments for today's first launch. With that, we'll go ahead and sit back and listen back to Mission Control.
All right, guys, let's do something different today. Different this time, okay? Let's give our best wishes to this rocket by hitting that like button.
We're currently priming
apparently.
the igniters with gaseous oxygen and gaseous hydrogen. Again, our ignition system uses these propellants flowing across a glow plug.
Okay. So they are apparently using, that means if they are using hydrogen and oxygen, no, then they are using electric spark plug to ignite a flame
5 minutes away.
in between them. So yeah, it looks I think that is what they're doing. So yeah, I was saying, hit that like button, guys. Give your best wishes, and hopefully this time it would fly. And look at that up the skirt, right?
GLHF
Whoa.
again is our maiden launch. So a nominal flight would have Terran 1 reach orbit today, but our main goal is to learn as much as we can about this vehicle and demonstrate the product concept. A major milestone would be for us to reach max Q today, the point of maximum dynamic pressure.
Yep. It's all 3D printed. Most of
Stage
it
2
is.
is on internal power.
Which means 3D printing integrity needs to be checked.
And the
TE cradle disengaged.
TE cradle, there we go, disengaged. You'll see that cradle arm slowly start releasing stage 2.
Oh god, no, this does
so that
not.
the starting back can retract.
Okay, cool. Hey, all right, T minus 3 minutes, 27 seconds remaining. Feels amazing. Now, just look at those gimbals. Oh, the the center one does not gimbal.
And you can see the engines gimbaling there. We're performing the final thrust vector control health checks on both stages right before liftoff. You can see stage 1
is on internal power.
Engines there.
All right, the center one does not gimbal in for this one, which actually makes sense also.
Shrunk back retracting.
And now that black truss structure will retract just a few degrees to prepare for umbilical separation. There it goes.
Stage 2 TVC checkout.
Oh.
As we approach T minus 2 minutes, just a reminder, the vehicle you're looking at is 85% 3D printed.
Yep. Not only the engines, they literally printed
Those
the
white
tanks
clouds
also.
you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid air that we have here in Florida. That's why it condenses into vapor and it looks like clouds that are floating out. You'll also see the flare stack on the bottom right there. That is just used to vent out flammable gases. Next up, our range coordinator will ask the range for their final status.
Please, no bots. No bots this time.
Rock, report range status.
Range green.
Range green! Yes! T minus
We
1
got
minute.
confirmation. Range
10
is
seconds
green
remaining.
for launch.
All right. Go, baby, go. And yes, terminal count. Vehicle is in terminal count now. This is happening, guys. This is happening. T minus 60 seconds remaining.
Flight computer and countdown.
Hit that like button and give your best wishes right now, guys, if you haven't already. Oh no. Dude, you were right, flying the bug.
Announcement on countdown, that is the LD. We've had a abort and terminal count. This is a final instantaneous T0 launch window. We are going to be scrubbed for the day. Safing up the vehicle. Thanks for playing.
I've seen the chat, guys. I've seen the chat. Oh god. Okay, this happened now at T minus 45 seconds. If that means the abort was actually decided by the computer, which means there was certainly something wrong and not because of any human intervention. So, whoa. So now that was the instantaneous launch window, which
Our
means
teams obviously gave it an amazing shot today, and we had high hopes for sending our Terran 1 off, but we're going to continue to take a measured approach so we can ultimately see this rocket off to max Q and beyond.
Once we have an update on the timing of our next launch attempt, we will share that via Twitter at Relativity Space. We hope you will join us again soon to see the world's first 3D printed rocket fly. I am Rachelle Aniceto.
And I'm Arwa Tizani Kelly. Thank you. See you next time.
wow, just look at those 3D printed. I did not notice those, but were they there or don't know? But yeah, there you go, guys. I kudos to them for giving all the efforts in the world. Like literally, they went on to try after the hot fire abort. But yes, this is how it is. So talking about if this mission happens tomorrow, so you can see a 24-hour delay means just 5% uh, probability of violating weather conditions, which means 95% go for the launch. But will that happen tomorrow or not? We'll have to wait and see. And now, hey Jason, welcome to the stream. So we got two wet dress rehearsal and SF. Yep, true. Well, we do have another launch scheduled, which is the Rocket Labs Electron rocket in just like 2 hours from now. Nope, that is not scheduled now. Wow, that has been rescheduled for some reason, which we don't even know the we don't know the next launch. Okay, what happened with that? Let's see. That was also supposed to launch, but is not happening. So it was Rocket Lab was launching it from Virginia only, the Wallops, but for some reason they are not launching it today. Today's launch attempt, due to strong upper level winds, we have backup opportunities over the next week, and we'll share a new launch target soon, launch date soon. Okay, cool. So upper level winds, this kind of happens when weather is actually clear. No, when there are no clouds, then upper level winds are kind of high. So there is a very sweet spot for these conditions to actually be favorable for a rocket launch. But yeah, this is how it is. And do we have any update here? Nope, nothing. So we are down. So for today, that's it for the relativity space. And talking about that playlist, no guys, if you scroll down a bit, here you go. The playlist which they play on their channel is from here, so you can choose between iTunes and Spotify, and if you like those tunes you can have that. And look at this engine also. So this is the engine, Aeon R engine. So this is different from what it is, what is flying, what was supposed to fly today. This is is this the real one? A second. It's not a real one, but maybe this is a more like a prototype for them. So yeah, more like a prototype, but you can see how it is. So it looks cool, right? Great. Okay, so we the next launch opportunity for them is tomorrow itself. Based on initial data review, the vehicle is healthy. More info to follow on the cause of aborts today. Thanks for playing in. Thanks for keeping us updated, relativity space. And there you go, guys. You have the update, which is in front of you. Jack, for me, it is right now around 2:40 2:35 a.m. So it would have already been difficult for me if the Electron would have launched today. So it's It's good that it did not, so I can plan for the next one. But the next launch which is coming up is from Russia now. The Proton is launching. Wow, Proton I can't miss, but um, yes, I can actually, but this is a top secret mission. This is military mission, so this won't be live streamed. All right. So the Dragon CRS-2 mission is gonna happen on 15th of March. I should be able to stream that. And then the SES-18, SES-19 is gonna happen. Okay. So OneWeb is also, oh, the ISRO is 6 to 10:30 a.m. ISRO is supposed to launch their OneWeb 18 stack, the GSLV Mark III launch on 26th of March. Hopefully, I'll be able to stream that. Let's see if that happens or not. But if that happens, oh, that would be great. Okay, guys. I think that should be it for today. I hope you liked it. And I hope you will come back to again also for this launch. So I should go and sleep now, but I don't know what's happening for you, if it's evening time or like how it is. If it is evening, then good evening for you. Good night. If it's night time, good morning. If it's morning time. All right. Thank you so much for tuning in, guys. Hopefully this one flies again the next time, and I shall be streaming it, so don't worry about it. Thank you so much for tuning in. And yeah. This is Pian Shurula. You just saw Rocket Gyan. Stay safe, stay healthy, and